This is the algorithm for how to union a set together. I'm not going to get into the details of what a set is and why it's important to use, but I'm just going to go right into how to solve one of these problems. This is the algorithm, like I said, right here, but you don't actually have to know this or memorize this. You can just refer back to what I'm doing. Feel free to pause and write this down if you want. But this is going to be broken down into 4 large steps. Essentially, you're going to have to find the end paths. That's this step. Then you're going to have to update the end path values. Then you'll have to update everything along the end path. And finally, update the remaining table. So it's sort of 4 big steps. So this is what a typical problem will look like. Show the union of 7, 2, and blah, blah, blah. Basically, what you're going to do is you're going to look at the first value, 7, and you're going to find the end path. All I mean by that is you're going to write down 7 right here, and you're going to say, what is 7 pointing to? Well, we're going to refer to these as containers, these numbers up here, and this is your sort of before table. Our goal is to fill in this after table. This container is not going to change. These are just containers. These will always stay as is. So the only numbers you need to update are these ones right here that are obviously currently empty. So you're going to update all of these. So you look at 7, which is the first value right here. If I can get my mouse to click it. There we go. We look at 7 and we say, okay, what is 7 pointing to? Well, up here, if we look at 7, the container 7 has 9 in it. So 7 points to 9. And we look at 9. What does 9 point to? 9 points to 8. Okay, perfect. And what does 8 point to? 8, as we can see, points to -4. Just like that. Okay, easy peasy. So we stop once we hit a negative, so we're done with that one. Now let's look at the second value, this one over here, the 2. So we say, okay, I'm not going to point out all of these, but 2 is going to point to 1. 1 is going to point to 0. 0 is going to point to 3. 3 points to -6, and since it's a negative number, we stop. Okay, so that is finding the end path. That is sort of the first big step. We find the end paths. And now what we're going to do is we're going to update the end path numbers. The end path numbers are 4 and 6. So the way to update them is we look at the 2 numbers and we determine the absolute value, which one is larger. Well, it turns out 6 is larger than 4, so we're going to update 6. If we look at the table, these are the 2 end path values because this is the 6 and this is the 4. So these are the 2 spots that we're going to update right here. So if we look at these, we can say 6 plus 4 is going to equal 10. So we take the larger value and we add the smaller value to it. So it's going to equal 10, but we still have to include that negative. So that's how you update the first value. The second value you update, the -4, is going to be different. You're going to update the second value to be whatever is holding the larger of the 2 values. So this place right here is going to be this container. So this guy will be 3 because it's the container for the larger value. So now we've updated the 2 end values. All we have to do now is fill in all of the endpoints along the path, and then we have to fill in the rest of the table with everything that was previously there. So I know I'm going a little fast, but let me show you what that looks like. The algorithm will say that we're going to update everything along the larger numbers path that isn't negative to be pointing to the container number of the larger number. What that means, sorry, it may seem confusing, but go through it a couple times and you'll see what I mean. What you're going to do is you're going to look at the larger number path, which is going to be this one. This has now updated and will be 10. So this is the larger number, 10. We say everything that is in this path, which will be a 2, a 1, a 0, and a 3, is now going to be updated to point to the path container. So this is the path container, 3. So 2 is going to point to 3, and 1 is going to point to 3, and 0 is going to point to 3. You get the idea. Let's get rid of these so you can see what's going on. So we look at 2. We say 2 now will point to 3. 1 will point to 3. And 0 will point to 3. We would update 3 to point to 3, but it contains a negative, so we don't update it. So we've updated this path right here. Now we have to do the same thing with the other path. So that would be this path right here. So we look at it and we update everything along the smaller numbers path that isn't negative to be pointing to the container number of the smaller number, if and only if it hasn't been updated already. So all that means is you're going to look at the container and you're going to say that 8 is what's currently holding this number. So you've got 8, that means 7 is going to point to 8, 9 is going to point to 8, and 8 won't point to 8 because it's itself, obviously. So we update 7 to point to 8, we update 9 to point to 8. This has already been updated, so we don't update it any more than that. And then the very last step was the easiest of the steps. Any of the numbers that we haven't filled in on the table, so that'd be these guys right here, 4, 5, and 6, are just the same values as they were before. So that means this is 2, this is 4, and this is 7. And voila, we've updated the table and we're done. So that's sort of the slow example. We're going to move on in the next video and show you a couple of the examples at full speed, and you'll see how it works. Hopefully that makes sense to you guys, so be sure to watch the next video because I'll go much quicker. Thanks for watching.